Hello, everyone, and welcome to Bookercast, the podcast where books come to life.
And I'm so excited to dive into another amazing story with all of you.
Whether you're a bookworm or just love a good story, this is the place for you.
Every episode, we explore incredible books, talk about their stories and characters, and share insights that'll make you fall in love with reading all over again.
All right, let's not keep you waiting any longer. Get comfortable, and let's jump right into it.
Sounds good.
All right, let's dive into Brian Greene's The Fabric of the Cosmos.
Yeah,
This book really tackles some big questions.
it does.
Space-time and what reality is all about.
Yeah, and it's written in a way that makes sense even if you're not a physicist.
Right. Greene does a great job of explaining things in a way that just clicks.
Totally. And you know what I really appreciate about Greene's approach? He doesn't just throw a bunch of complicated theories at you.
Right.
He takes you on a journey through how our understanding of the universe has evolved.
Oh, I see.
Like starting with Newton's ideas and then diving headfirst into Einstein's incredible theories.
It's like witnessing a scientific revolution.
Exactly.
And you know what? Right from the beginning, Greene sets up this classic debate about space.
Okay.
Is it like
Yeah.
a real thing or just a way to describe how objects relate to each other?
Right.
Newton was firmly in the space is real camp.
Yeah.
But then we have Mach who comes along and says, well, hold on a second. Maybe space is just a concept? And then comes Einstein, who just shakes everything up.
Oh, yeah.
With his theories of relativity, he basically shatters this idea of space and time as separate entities. Instead, he shows us they're woven together
Yes.
into this amazing flexible fabric called space-time.
Oh, base time.
And get this, space-time isn't some fixed thing.
No.
It's relative, meaning it can be experienced differently,
Yes.
depending on how you're moving through it.
It's mind-blowing, isn't it?
Mind-blowing is an understatement. So how does Greene make this, this concept of relative space-time something we can actually grasp?
Well, he uses a clever analogy.
Okay.
A spinning bucket.
A spinning bucket.
Yeah, simple, right?
Sounds simple.
But it perfectly illustrates how Einstein moved beyond thinking of gravity as just a force.
Okay, we all learned in school that gravity pulls us down to Earth.
Right.
It's why things fall.
Exactly.
But Einstein's theory changes things up a bit.
It does. It tells us that Earth actually warps the fabric of space-time around it. So we're not really being pulled down. We're just following the curves of space-time.
Okay, so it's like,
Yeah.
imagine a bowling ball on a trampoline.
Yes. Perfect example.
It creates a dip, right?
Right.
That's Earth warping space-time.
Exactly. And we're like little marbles rolling around that dip.
I'm starting to get it.
It's not that we're pulled toward the bowling ball.
No.
We're following the curve of the trampoline.
Okay.
Greene also uses this loaf of bread analogy.
Loaf of bread.
Yeah, to visualize this, which helps to explain the weird stuff about time and relativity.
All right, I'm intrigued. Tell me more about this loaf of bread.
Okay, imagine space-time as a loaf of bread.
Okay.
Different observers, they're like slicing the loaf at different angles.
Okay.
What one person sees as happening simultaneously, someone else might see as happening at different times.
Because they're slicing the loaf differently.
Exactly.
Wow. So depending on your perspective, your movement through space-time,
Yes.
your perception of time can change.
It can. Time itself is relative, not just space.
It's like all my basic assumptions about the universe are being challenged.
It's just the beginning.
This is mind-blowing.
Wait until we get to the quantum world.
Oh boy.
Greene dives into that too. Think about quantum entanglement,
Okay.
where particles are linked across huge distances.
I've heard of entanglement,
Yeah.
but it's always seemed kind of mysterious.
It's definitely weird.
Does Greene tackle this in the book?
Oh, absolutely. Entanglement throws the idea of separation right out the window.
Okay.
You can have two particles light years apart,
Right.
but they're still connected in this spooky way.
Spooky.
It's like they have this secret communication channel that ignores the limitations of space.
So if these particles are so far apart,
Yeah.
how can they still be linked?
Well, to explain that, he takes us back to the double slit experiment.
Right. The one that shows a single particle can act like a wave,
Exactly.
suggesting there's a fuzziness to its past.
It's like the particle doesn't decide on a path until we try to measure where it is.
So it's like reality is waiting for us to make a choice before it decides what happened.
It's a strange concept. Even Einstein had trouble with it.
Really?
He called it spooky action at a distance.
Even Einstein?
Even Einstein. He was convinced that nothing could influence something else faster than the speed of light.
So Einstein, one of the most brilliant minds ever,
Yeah.
had a hard time accepting this idea.
He did. But here's the thing. Experiments later on actually confirmed these spooky connections are real.
Oh, wow.
Scientists like Elaine Aspect did experiments in the 80s.
Uh-huh.
That forced everyone to rethink how space and separation work.
So even Einstein, with all his genius, couldn't argue with the experimental evidence.
Nope.
That's fascinating. Shows how science works. You need both brilliant theories and solid proof.
Exactly.
And you know what? We're just scratching the surface here.
I know.
This has been a lot to take in.
We've got so much more to explore.
What else is coming up as we delve deeper into the fabric of the cosmos?
Well, get ready for time travel, the Big Bang.
Okay.
And even the quest for a theory that unifies everything we know about physics.
This is going to be wild.
Buckle up. It's going to be a mind-bending ride. One of the things that makes the fabric of the cosmos so cool is how Greene brings in these philosophical questions
Right.
alongside the scientific ones. It's not just about equations and experiments.
Well,
it's about what these discoveries mean for us, you know?
Totally. Like, what does it all mean?
Yeah, exactly. He digs deep into these big questions about reality, time, even free will.
Yeah, it's pretty deep stuff.
And he doesn't shy away from the mind-bending stuff either.
Like what?
Like the idea that our experience of time flowing, you know, that feeling of moving forward might be an illusion.
Whoa.
Yeah, a total illusion. He lays out this idea called the block universe,
Okay, a block universe.
where if you really take space-time seriously, all moments, past, present, future, they might all exist at once.
So you're saying my past, present, and future are already laid out, like a frozen river or something?
Kind of like that, yeah.
Yeah.
It's a tough one to wrap your head around.
That's crazy. So how does Greene connect this to what we were talking about before? Like entropy and the arrow of time?
Well, he suggests that our experience of time moving forward, that arrow of time, might be linked to the increasing entropy of the universe.
Okay, remind me again, what's entropy?
Entropy is like a measure of disorder.
Right.
And the second law of thermodynamics says that entropy, it generally increases over time.
Like the universe is winding down.
Yeah, exactly. It's slowly winding down, and that directionality, that's what we perceive as the flow of time.
So instead of time being this thing that's moving forward,
Yeah,
maybe it's just our perception of the universe becoming more and more disordered.
exactly. It's a big shift in thinking, isn't it?
It is. Does Greene bring this all the way back to the beginning of the universe?
He does. He spends a good chunk of the book talking about the Big Bang. And he makes it clear that while the Big Bang theory explains how the universe evolved, you know, from this very early state, it doesn't actually explain what caused the bang itself.
That's a good point. It's like we have this detailed map of the universe, but we're missing the starting point.
Exactly. We can trace it back to this initial moment, but what happened before that?
Right. Was there even a before?
Yeah, those are the big questions.
So what does Greene say about those?
Well, he goes into inflationary cosmology.
Inflationary cosmology.
Which is this idea that the universe went through this period of super rapid expansion, like in the first fraction of a second after the Big Bang.
Okay.
And he explains how inflation can help explain some things that the standard Big Bang theory couldn't.
So it's like adding a prologue to the Big Bang story.
Yes, exactly.
Okay, what kind of things can inflation explain?
Well, for example, why the universe looks so uniform on a large scale. And also those tiny temperature fluctuations in the cosmic microwave background radiation.
The stuff we talked about before.
Yes, exactly.
So inflation fills in some gaps.
It does.
But it still doesn't answer where it all came from, right?
Right. That ultimate origin is still a mystery.
Right.
But one of the really cool things about inflation is that it's linked to quantum mechanics.
Which brings us back to the quantum world.
Full circle.
It's like all these pieces of physics are starting to fit together.
They are.
So you're saying the large-scale structure of the universe, all those galaxies, is influenced by the quantum world.
Exactly. Those tiny quantum fluctuations during inflation,
Okay.
they're thought to have been the seeds for the large-scale structure we see today.
Wow. So the quantum world is imprinted on the cosmos itself.
It's pretty amazing, right?
But hold on. We said earlier that general relativity and quantum mechanics don't really get along.
Yeah, they have their differences.
So how do we reconcile those two theories?
Well, that's where string theory comes in.
String theory, okay.
This is one of the most exciting parts of the fabric of the cosmos.
And speculative.
Definitely speculative.
We touched on it before.
Yeah.
So remind me, how could string theory help unite these two seemingly incompatible areas of physics.
Well, string theory has this potential to create a unified theory,
Okay.
one that brings all the forces of nature together,
Mm,
including gravity. It's a big, bold theory,
it is.
and it comes with some pretty mind-bending implications.
Like what? Hit me with those implications.
Okay, so one of the most radical is the existence of extraspatial dimensions.
Wait, extra dimensions?
Extra dimensions, yeah.
Like a fourth dimension, a fifth dimension?
Exactly, beyond the three that we experience.
Okay, now you're really messing with my head.
It's wild, isn't it?
So what does Greene say about these extra dimensions?
Well, he explains how these extra dimensions could be curled up.
Curled up.
Yeah, at these incredibly small scales, so tiny we can't see them.
So they're like these hidden dimensions all around us.
Yeah, exactly, like a hidden reality.
So even though we can't see them, they're influencing our reality.
Yeah, the geometry of these extra dimensions
Okay.
could influence the properties of particles and forces in our 3D world.
It's like this whole other level of reality beneath the surface.
Yeah, pretty cool, huh?
Okay, so string theory says everything is made of these tiny vibrating strings.
Yeah.
And there are these hidden dimensions shaping our reality.
Mm-hmm.
But how can we test any of this? It seems very theoretical.
That's the big question. Testing string theory is tough, but Greene talks about some promising avenues.
Like what?
Like searching for supersymmetric particles.
What are those?
These hypothetical particles that string theory predicts.
So like every particle has a secret twin.
Yeah, kind of like that.
That's cool.
And another way would be to detect microscopic black holes at particle accelerators.
Black holes created in a lab.
I know, right?
That's both amazing and scary.
It would be a huge discovery.
Yeah.
And further observations of the cosmic microwave background radiation.
Oh, okay.
That could also provide some clues.
About string theory.
Yeah, potentially.
So it's early days for string theory,
It is.
but lots of exciting possibilities.
Absolutely. And even if string theory isn't the ultimate answer,
Right.
the insights it's given us about space, time, quantum gravity,
Yeah.
they're already changing how we understand the cosmos.
This conversation is making me realize how much I took for granted about how the universe works.
It's a lot to take in, for sure.
What else does Greene explore in the fabric of the cosmos that might challenge our assumptions?
Well, one topic that always gets people excited is time travel.
Okay, time travel. Now we're
Greene doesn't shy away from it.
Hasn't science pretty much ruled that out?
Not necessarily. He acknowledges the challenges.
Right, paradoxes and all that.
Yeah, but he doesn't dismiss it completely.
Mm.
He explores some theoretical possibilities, like wormholes.
Wormholes, like those tunnels through space-time.
Exactly, like shortcuts through space.
From science fiction.
Yeah, those ones.
Okay.
He also discusses manipulating space-time itself to create something called closed time-like curves.
Closed time-like curves.
Yeah, they're basically paths through space-time
Mm-hmm.
that could allow you to travel back in time
Whoa.
and meet your younger self.
So time travel to the past isn't completely off the table.
It's theoretically possible.
But wouldn't that create all sorts of paradoxes?
Yeah, like the grandfather paradox,
No.
where you go back and accidentally prevent your own birth.
Oh, right. Classic.
But Greene doesn't just leave us with the paradoxes.
Uh-huh.
He talks about some potential solutions, like parallel universes.
Okay, parallel universe.
If you travel back and change something,
Right.
you might be creating a new branch of reality.
A whole new universe.
Exactly. A parallel universe rather than messing up your own past.
This is mind-blowing stuff.
It is.
Okay, we've covered space-time, relativity, quantum mechanics, string theory, even time travel. What else is in the fabric of the cosmos?
Well, we've been talking about space-time like it's this fundamental thing.
Right, the fabric of reality.
But Greene also hints that space-time might not be so fundamental after all.
Wait, what? Space-time isn't fundamental.
It's a question physicists are wrestling with.
I thought that was like the bedrock of everything.
Yeah, it seems that way.
What could be more fundamental than space-time?
That's the mystery, right?
Yeah.
Greene talks about research that suggests space-time might be an emergent phenomenon,
Emergent.
arising from something even deeper.
So space-time is like an illusion, a way of describing reality at large scales, but breaks down at the quantum level.
Yeah, that's one way to think about it.
Trying to wrap my head around that.
It's a tough one. He talks about several lines of evidence that point to this emergent nature,
Like what?
like the holographic principle,
Okay.
which suggests that the information content of a region of space is actually encoded on its boundary.
So like the universe is a giant hologram.
It's a wild idea, right?
Yeah.
And there's also evidence from black holes that supports this.
Black holes. Those things that suck everything up.
Those ones.
What do black holes tell us about space-time?
Well, according to general relativity, black holes are regions of space-time where gravity is super strong.
Right. So strong, nothing can escape.
Not even light, yeah.
Okay.
But here's where it gets interesting. Black holes also have temperature and entropy, which are properties we usually associate with systems that have lots of microscopic degrees of freedom.
So black holes are more complex than we thought.
It seems so.
What does that have to do with space-time?
Well, it suggests that there's something going on inside a black hole that we don't fully understand.
Okay.
Something not captured by our current understanding of space-time.
Hmm.
Some physicists think the information that falls into a black hole,
Right.
it might not be lost forever,
Okay.
but could be encoded on the black hole's event horizon.
Which...
That boundary beyond which nothing can escape. It's
Oh.
like the point of no return.
So black holes are testing the limits of physics.
They are, forcing us to rethink space-time itself.
This is heavy stuff.
Ew.
So if space-time isn't the foundation of reality, what is?
That's the big question. What could it possibly emerge from?
It's amazing and a little bit scary to think about what might be holding this whole reality thing together.
It is.
Well, I'm ready to keep exploring these ideas.
Yeah.
What possibilities does Greene suggest for what might lie beyond space-time?
Well, he talks about the possibility that space-time might be woven from, get this, quantum entanglement.
Quantum entanglement, the spooky action at a distance.
That's the one.
So the fabric of space and time, the thing we've been talking about this whole time, might be held together by those spooky connections.
Yeah, it's a wild idea.
Are there any theories that actually support that?
There's some interesting work, yeah. One example is the ER-EEPR conjecture.
ER equals EPR. What's that?
It's an acronym.
Oh.
Two famous papers in physics.
Okay.
ER stands for Einstein and Rosen, who wrote about wormholes.
Right.
EPR stands for Einstein, Podolsky, and Rosen, who wrote about entanglement.
Ah, I see.
The EPR conjecture basically says these two things, wormholes and entanglement, might be two sides of the same coin.
So a wormhole, a tunnel through space-time, could be the same thing as a pair of entangled particles.
That's the idea.
Wow.
It's still very speculative, though.
Right.
But it shows how quantum mechanics and space-time could be connected.
It's like we're just starting to glimpse this hidden language of the universe.
Exactly.
We're seeing connections between things that seemed totally separate before.
And who knows what we'll discover as we learn more.
Yeah, maybe space-time is just one layer of much deeper reality.
It's exciting to think about.
A little bit scary, too.
Yeah, it challenges us to really think outside the box.
Well, this whole deep dive into the fabric of the cosmos has been quite a journey.
It has.
We've gone from tiny particles to giant structures in the universe, from the beginning of time to the edge of reality.
Lots to think about.
Brian Greene really has a way of making these complex ideas accessible.
He does. He's got that gift for explaining things clearly and making it fun.
Yeah, and I think beyond just understanding the science, this book really makes you think differently about your place in the universe.
It does. About the nature of reality itself.
So for anyone listening who's feeling curious about all this, why should they pick up The Fabric of the Cosmos?
If you want to explore the biggest questions about the universe and have your mind blown wide open,
Yeah.
this book is for you. Brian Greene takes you on an incredible journey through the frontiers of physics.
And he does it in a way that anyone can understand.
Exactly.
So if you've ever looked up at the night sky and wondered what it's all about, Brian Greene's The Fabric of the Cosmos is a must-read.
It'll make you think about the universe in a whole new way.
Thanks for joining us on this deep dive.
It's been a pleasure.
And until next time, keep exploring and keep asking those big questions.
And that's a wrap for today's episode of Bookercast. We hope you enjoyed diving into it as much as we did. Thank you so much for spending your time with us. Your support means the world, and we can't wait to hear your thoughts on this episode.
Don't forget to subscribe, hit that like button, and share this episode with your fellow book lovers. And let us know your thoughts in the comments below. We love hearing from you. See you in the next deep dive. Bye for now, and happy reading.